Welcome, my dear learners. In today's lesson, we shall be looking at derivative of general exponential function. So, when we talk about general exponential function, we are talking about a function of the form a exponent g at x, where a is a constant and it is called the base of the function, and g is the function of x, and we know that x is also a variable. And examples of these general exponential functions are when you have, let's take it that you have y is equal to 7 exponent x. Now we all know that 7 is a constant and it is raised to a power of x, which is a variable, so we can classify this function as what? A general exponential function. Also, when you have the function f at x, which is equal to x, which is equal to 8 exponent x squared plus 1. Now, we all know that 8 is a constant a number and it is raised to a power of a variable of x. So you can say that this also becomes what? A general exponential function. I believe you are following. Now we have the third example. We can also classify this as a general exponential function, and this is also a classical example of general exponential function. Now, let's see how best we can find the derivative of this general exponential function or function of this nature. How are we going to find the derivative? The derivative is also known as the slope. It is also known as what? The gradient of this very function. How are we going to find it? Now, to do that, let's go through these very steps. So these are the steps that is going to guide us to find the gradient, the derivative of these very functions. So let's go through it. So the first step is saying that we first have to repeat the function. The function that we have been given, just repeat the function. Then the second step is saying that take the lane of the base. So we identify the lane of the base, and we know that the base is what? The a. So the base from here, our base is 7. From here, our base is 8. From here, our base is 7. From here, our base is what? 10. So we identify the base and then we take the length of that. And then the third step is saying that we differentiate the exponent. So we are going to identify the exponent. So from here, the exponent is x. From here, our exponent is s squared plus 1. Here, our exponent is s cubed plus 3. And then this one, our exponent is root of s plus 2. So we identify them, then we find the derivative of the exponent. And then the last step says that we multiply I, and then I together. And that is going to give us what? The derivative of that function. So let's take examples and then see how best we can apply these methods. So we have our first example here, which says that we have to find the derivative of this very function 4 power x. So this is a general exponential function of this very form. So we can apply these very steps. Okay, so let's start. So the first says that we first repeat the function. So to find the derivative or the gradient or the slope, you know that our f prime at x, which is the derivative, which is the same as the y dx, is we repeat the function. So the function is the whole of this. So we are going to repeat it. So that is 4 power x. Now the second says take the length of the base. So what is the base? So we know that the base is what? The base is 4. So we take the length of the base. So we have length 4. That is what this step says. So length of the base, so we have length 4. And then we differentiate the exponents. So we have, let me put them together. So we take the length of the base, which is 4, and then we differentiate the exponent. So we know that when we differentiate x, what are we going to get? So let's move to the next step. So we are going to have 4 power x multiplying the length of the base, which is 4, and when we differentiate x, we are getting what? 1. Therefore, the derivative of that function above is giving us 4 power x ln 4, and that is that. Very, very simple. We take our next example. Example 2. Given that the function y is giving us 8 raised to the power x squared plus 1. We have to find the derivative of this very function. So we know that this is a general exponential function of this very form, so we can apply these very steps. So we know that our derivative, which is giving us dy dx or y prime at x, is the same thing of this general exponential function. We first what repeat the function. So we are going to repeat the function. The function is that, and then we multiply it by what? By the length of the base. So we know that the base is 8. So we take the length of the base, which is what? 8. Then we multiply by the derivative of the exponent. So the derivative d of what? Dx of x squared plus 1. This is the exponent. So let's continue. We are going to get, so we have 8 x squared plus 1, and we know the length of 8 is already there. And then when we differentiate this power, which is x squared plus 1, we differentiate x squared, we are getting what? 2x. And whenever we differentiate a constant, we get 0. So therefore, our derivative for this very function is going to be, so we have 2x ln 8, then we have 8 exponent x squared plus 1, and this becomes the derivative of the function. We take our next example. So we have our text example. We have the function 3 power root of x. We have to find the derivative. So we know that it is a general exponential function. So we apply the rules. We first have to what? We know that our derivative, which is giving us y prime at x, is we repeat the function. So the function is the whole of this. So let's repeat that. 3 root of x. Then we take the length of the base. So the base is what? 3. So we have the base, which is what? 3. So we have length 3. And then we find the derivative d, the derivative of the exponent. The exponent is what? Root of x. So we know that we have solved this severally in our previous lesson, root of x. So the moment you come across root of x, the derivative, in fact, don't calculate, don't think. It's just 1 over 2 root of x. Good. So we are going to get 3 root of x, length of the base, which is 3, and then the derivative of root of x, as I said, is 1 over 2 root of x. We've solved this severally in our previous lessons, so we're not going to calculate that. So we can rearrange this to be in the form of, we have 3 root of x ln 3 all over 2 root of x. Very, very simple. So finding the derivative of general exponential functions are not all that very difficult. They are very simple. Just follow the steps and then you are good to go. We take our next example. So we have our fourth example. We are being given the function y equals 7 exponent root of x power 4 plus 9. We have to find the derivative of this very function. It might look cumbersome, okay, but it is going to be very simple. So let's go through. So we know that this is what? A general exponential function of this very form. So we can apply these very steps. I hope you remember. So let's apply them. Now, the step is saying that to find the derivative of that, we are going to first repeat the function. So we are going to write our derivative y prime at x equals, so we repeat the whole of this function. So we are going to do just that. So we have repeated the function. Now we take the length of the base. The base is what? 7. Then we find the derivative of the exponent. So the exponent is giving us x power 4 plus 9. So it means that we are just going to find the derivative of this root of s power 4 plus 9. So we know that this can be written as x power 4 plus 9 raised to the power half. We know that half is the same as what the radical sign. Good. Now when you write it in the form of this, we are having two functions, a function of half or a function of root sign and a function of what, s power 4 plus 9. So we are having a function of function or a function within function. And if that happens, then we can apply what? The chain rule. I believe you remember the chain rule. If you have forgotten, kindly go back and watch the previous videos on chain rule. So in doing that, the chain rule says that we differentiate the outside function, which is half, and then we multiply it by the derivative of the inside function. I guess remember. Good. So let's find the derivative of that, and then we come and add it to this very part. So we are going to get, chain rule says that we find the derivative of the outside. So in the outside, we are going to apply the power rule. So this half will come in front. Then we write what is inside the bracket. Then we subtract 1 from the exponent. Don't forget, you subtract 1 from the exponent. And when you subtract half minus 1 from half, you are going to get minus half. And then the second thing is we multiply it by the derivative of the inside function. So the inside function is x power 4 plus 9. So when we differentiate x power 4, we are getting what? 4x power 3. And when we differentiate a constant 9, we are getting what? 0. So we can say that the derivative of this root of x power 4 plus 9, we are going to get, let's simplify it. When you simplify this, we are going to get 4x power 3 all over 2. You know that this can be written in the form of x power 4 plus 9 raised to the power half. Good. So the derivative of this is that. So you just come and add it to this very part. So we have our final derivative, which is 7 power root of x power 4 plus 9 times ln of 7 multiplying 4x power 3 all over 2x power 4 plus 9 raised to the power half. We can just rewrite it so that it can be in a very nice form, okay? But I can leave your answer at this very point if you are stuck. But let's all solve it together so that whenever you reach there, you see how best you can write it in a very nice form. So we know that the whole of this times this is going to be 4x power 3. Let's rearrange it. We are just rearranging it all. Then we have ln of 7 multiplying 7 power root of x power 4 plus 9. Then we have all over 2. Now we know that half is the same as the radical sign. Good. So we are going to have, we take the square root of x power 4 plus 9. Very good. And this becomes the derivative of this very function. You see how simple it is. So we have our fifth example. We have to find the derivative of this very function. So we have a function of x plus 1 raised to the power 10, and then a function of general exponential function. So we are going to treat them as such. Now you can see that this is what the sum rule. So we are going to apply the sum rule to find the derivative of this, which means that we are going to differentiate each of the function term wise. Okay, so we take the first one. We know that our y prime at x, which is the derivative, is going to be, we differentiate, let me use this word pen, we differentiate x plus 1 raised to the power 10 plus, we take the derivative of 10 power x squared plus 1. So this is what we are going to do. So we differentiate them term-wise. I believe you are following. Good. So we know that we have x plus 1 raised to the power 10. We have two functions, a function of a power of 10 and then a function of what, x plus 1. So we have a function of functions or a function within function. So we apply the chain rule. It's very necessary. We apply the chain rule. So the chain rule says that we differentiate the outside function. So the outside function is to the power of 10. So we are going to apply the power rule for the outside function. So we are going to get 10. We repeat what is inside the bracket, then we subtract 1 from the exponent. So we'll be left with what? 9. And then after that, we differentiate what is inside. So when we differentiate the inside, we are getting what? 1. So we are going to get 10x plus 1 raised to the power 9. And that is the derivative of what? This very part. Now let's move on to the derivative of this very part. Now this involves general exponential functions. We are just going to follow the steps. We repeat the function. So we are going to get, for this very part, we are going to get, repeat the function. So the function is what? 10 power x plus x squared plus 1. Then we take the length of the base. The base is 10. Then multiplied by the derivative of the power or the exponent. So we know that the exponent is x squared plus 1. Very good. So we are going to have x squared plus 1. Then we have our length of 10. And then when we differentiate x squared, we are getting what? 2x. And when we differentiate a constant, we are getting 0. So let's rewrite this nicely. So we are going to get 2x length 10, and then we have 10 x squared plus 1. So we just add this and this together to give us the derivative. So we can see that finally our derivative is giving us we have 10x plus 1 raised to the power 9. Then we have plus the whole of this 2x length of 10. Then we have 10 x squared plus 1, and this becomes the derivative of this very function. It's not difficult, my dear. You can do it. We are going to take the last example, and I'll give you one for you to try your hands on it, and make sure you write your answer in the comment section. So we have our function, which is y equals x power 4 multiplying 5 power x. So the function is y equals x power 4 multiplying the general exponential function 5 exponent x. We have to find the derivative of this very function. So you can see that we are having two functions, x power 4 and then 5 power x. So since there are two functions multiplying, what do we do here is we just apply what? The product rule, which says that we keep the first function, we differentiate the second function, we keep the second function, we differentiate the first function. So let's write the formula down for product rule so that it will serve as a guide. So we know that we have u v prime plus u prime v. So u means we identify the function of u, and then we identify. So let's call this function u and then this function v. So we are going to let our u equals x power 4. Good. And then our v is equal to what? 5 power x. Good. So we find our u prime. So we have u prime here, that is the derivative of u. So we are going to get our u prime to be what? When we differentiate x power 4, power rule, we are going to get 4x power 3. and then v prime. Now you know that this is what a general exponential function. So we apply the steps. So we are going to repeat the function. So the function itself is 5 power x. We take the length of the base. The base is 5. And then we find the derivative of the inside of the exponent, sorry. So we are going to get 5x power x, length of 5. And then when we differentiate x, we all know we are having 1. Good. So finally, this is going to give us 5 power x, length of what? 5. So we just substitute the functions and their derivative into the product rule formula. So we are going to get our y prime at x, which is equal to our u. Our u is given as what? X power 4. And then our v prime, this is v prime. Good. So let me write it down here so that you see it well. So we are going to have our y prime at x, that is the derivative. So we have our u. Our u is what? X power 4. Good. And then our v prime is what? We have 5 power x, length of what? 5, that is the base. And then we have our plus. Then we have u prime. Where is u prime? So this is that. 4x power 3. And then multiplying v. Where is v? Our v is what? 5 power s. Good. So I think we are done. Yes, so we are done. So we can leave our answer in this very form. So this becomes the derivative of this very function. So I'll give you one for you to try your hands on it. Make sure you write your answer in the comment section, and I will be responding to your answers in the comment section. So this is the try work that you can try your hands on it. We have the function f at s is equal to the root of 7 power x plus root of x. It might seem cumbersome or difficult, but it is very, very simple. Just go through the steps and then you are good to go. Thanks for watching. Bye bye.